Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland. Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en hier naast mij zit natuurlijk...
Jan Stomphorst, Solutions Architect. Powered basis.
Ja, nu in één keer goed.
Ja. Je probeert me elke keer van mijn stuk te werken, maar dat gaat me niet lukken.
We hebben er nog één te gaan. Dus
ik blijf aan mijn kopje thee met honing.
Hey, nou we hebben we twee mooie gasten hier aan tafel zitten. Ik zou gelijk maar switch to English.
Switching to English.
Yeah, so I'd like to welcome Mohamed Nasser.
Yes.
And Thierry Carrez.
Perfect.
Yeah, I hope the pronunciation is in the right direction. Mohamed, can you please introduce yourself to our listeners?
So my name is Mohamed Nasser. I've been in open source for maybe 15 years or so, a bit more maybe even. And I'm the CEO at VEXXHOST, but I also maintainer of a couple of open source projects, as well as I'm a board member on the OpenInfra Foundation.
Okay. And what got you started in the IT?
You know, the actual lore that not a lot of people know is when I was really young, I told my parents I wanted a PC so I can play video games on it.
Of course.
And they were like, money doesn't grow on trees, so go figure something out. And so at the time I had a computer, and the easiest way to make money when you're like young and you're too young to maybe get a job at a fast food place or something is play around with the computers. So I kind of from there slowly got an interest, and my father sort of pushed me in that direction. And then here am I many years later playing with all of this.
Cool. And you're the CEO of VEXXHOST?
Yes.
Well, can you tell us about VEXXHOST?
Yeah, so VEXXHOST, what we do is, we provide sort of a large stack of infrastructure as a service components. So everything from the sort of basics like bare metal, sort of automated bare metal provisioning up until sort of Kubernetes as a service, either on-prem or not, and then going up the stack into something like OpenStack, which is a little bit more specialized if you're looking for sort of a multi-tenant in-house sort of open infrastructure solution.
Okay. Thierry, can you introduce yourself to our listeners?
Right. I'm Thierry Carrez, the general manager for the OpenInfra Foundation, which Mohamed just mentioned, but also the general manager for the Linux Foundation Europe. And it's been quite a journey since my humble starts in open source in 1999, I guess. My first FOSDEM was like 2002. Right. So it's like I've been involved with the Gen 2 project, the Gen 2 Linux project at the very start, then hired at Canonical and to work on the Ubuntu server, and then started the OpenStack project back in 2010. And then moved to the OpenStack Foundation, which became the OpenInfra Foundation. And the anecdote I like to talk about in terms of, like, I'm much older than Mohamed is, in terms of computers, is I've been downloading software from wireless networks since 85. Because back then you would type computer programs, they would publish newspapers with source code, and you would type them, and there would be radio stations. That's what, like, the podcast environment makes me think about it. There would be radio stations that would broadcast the tape recording of the software that you could load up on your TI 99.4a or your Amstrad computer. And so I was back in that situation back in 85, like explaining the game I just typed in, and that people would listen to for the next 15 minutes. Forever. That was crazy times.
Like downloadable content and the radio waves.
Right. And fast forward to the AI craze. It's been a wild ride for sure.
Yeah. Yeah. So the same question. What piqued your interest when you were younger to go into the IT?
Computers. It's like I wrote computer programs at that age, I was 12, I guess. Yeah. And like just being able to make a machine do something, I was like really really liberating, I guess. And so moving on to engineer studies, where I worked on computer administration, then moving on to actually work on open source software, which is like liberating again, because it's so much of a space for collaboration and making new friends, and up to now. So it's been an interesting path, I guess.
Yeah.
So you're from the OpenInfra Foundation and the Linux Foundation also. I was a bit searching around. And OpenStack is the big issue. Is that still relevant today?
Oh, that's always a hot topic to talk about, people. I think it's more relevant than it used to be. I think there's a lot of different things that are happening right now in our world that are making it a lot more relevant. I think, especially at this KubeCon, there's a lot of people I talk to that are like, we have to be sovereign. We cannot rely on hyperscalers. Hyperscalers are mostly coming in from one place, and people are trying to not be fully dedicated off of that one place. That's a big factor. Other factors, not mentioning names, is large acquisitions that have made things difficult for folks who are doing virtualization on premise.
Oh, name names.
Okay, everybody knows who you're talking about. Yeah, yeah. So I mean, those two, I'd say on their own have kind of like revitalized it in such a massive way. At least I kind of see it from like kind of the commercial side of things. I see it, but I also see it sort of like in the community and the interest. But I feel like Thierry probably has more to add on that, since he has a bit more of a full ecosystem view that he sees across orgs as well.
Yeah, because maybe not everybody is familiar with OpenStack. So
yeah, I can explain a bit. So when we started it was extremely relevant because we badly needed an open source alternative to VMware and Amazon Web Services, which were like the dominant platforms for private infrastructure and public infrastructure back then. There was like really a need for more diversity in that space. There was like they were owning completely those spaces. So there was a lot of excitement into building an alternative to that using open source software. And like a lot of people just got together to line up behind that effort. It was the only one that was really openly governed. So everyone was feeling free to join. So that really captured all the attention. And then I guess between, I would say 2016 and 2020, maybe, there was like less attention. We had Kubernetes really going up with like being the interface to programming, and then you could run it on top of hyperscaler or your own cloud. So why would you run your own infrastructure? How about you just use the hyperscalers mostly from the US? And that was like obviously when interest in OpenStack was weighing down, because we like, why would you go through the hassle of providing infrastructure when you can just consume it from someone else? Until we enter the modern era, where clearly I would say our technical dependencies with other countries become much more of a open question, right? And
True.
And suddenly OpenStack is relevant again, because we have established relationships with companies, single companies, or countries, and they're leveraging that vulnerability against us. Like the company that shall not be named just changed the licensing practices because they could. They had that lock-in. They had that capture of the market. That country that should not be named is able to leverage the dependency, the digital dependency that we have established with the hyperscalers, and leveraging them in geopolitical discussions. And so suddenly the world realizes that like that convenience that they had between 2016 and 2020 was probably to their expense. And so they're coming back to OpenStack as like, how can I make my cloud native stack sovereign? Well, how about you just use like from the ground up, you run your own infrastructure and you use OpenStack at the lower layer. Will give you flexibility. You can run Kubernetes clusters, you can run VMs, you can run multi-tenant isolation, you can run all of that through OpenInfra software, and it becomes a lot more relevant now. People realize that they should have paid attention to it before.
Yeah, it's like what you said. It's everybody wants to go to the public cloud, There was the trend by everybody should go there.
It's convenient.
All companies said cloud first.
No, but there were a lot of private clouds, and they say, we cannot compete.
Yeah.
In this regard, the functionality that they offer, and everybody wants to go there. The marketing behind the hyperscalers was insane.
And Mohamed can testify. It's a complex job. Like providing infrastructure, you have to know about compute, storage, networking, those primitives that are not that. We were very happy to ignore that. We were very happy to outsource that to someone else, and yet that was probably not the best choice we made.
Yeah. There's a lot of competition on that market also, because you've got CloudStack as one of the biggest we see it as a big competition. Do you see that as a big competition also?
Not.
I'll take it. I don't ever see like different open source projects. Like it's hard to paint competition, right?
No, okay, it's a different.
Yeah.
But
I think for me, like, let's say someone, was to get on a call today and say, why should I use OpenStack versus CloudStack, let's say.
Or Kubernetes.
Or Kubernetes, yeah.
Because you've got Kubernetes in Kubernetes, and you've got a VV cluster.
Yeah. So one of the things that I always talk about when it comes to that is Kubernetes is really fun and easy to work with. When it's virtualized, it's a lot nicer. Maybe we all forgot how much painful it is to work with bare metal and how long things take to boot. Like just the idea of booting a system is like, it's like 10 minutes until you're actually, right? Like it is testing memory and doing all that stuff. And so, for example, in a high velocity environment where you might be tearing things down and bringing things up, going on bare metal is really slow. It takes time to do that. And the iteration cycle of like getting it up, getting it down and whatnot. The other thing is like OpenStack doesn't use any like innovative virtualization technologies. It uses KVM for the most part. And KVM's historically performance, differences of virtualization, you're like 99 point something % of metal performance.
But at Kubernetes, if you run VEXXHOST in Kubernetes, you use KVM.
Yeah.
CloudStack uses KVM.
Yeah.
They all use the same hypervisor layer, because that's a good hypervisor layer.
Of course.
Completely agree. That's the best one.
Yeah. And I think with like the OpenStack, there's what is really strengthened that is just like a really strong and big ecosystem. So for example, you've got, a Go SDK that's maintained by a bunch of people, Go for Cloud. You've got, Ansible collection that covers a lot of the OpenStack services, not just raw compute. We're talking about load balance as a service and all the other things that come along in a cloud that you expect or your users might expect from something like a public cloud, like block storage services and object storage services and all these other components that come along. And I think the multi-tenancy model also is very, very strong and baked from day one. So OpenStack sort of came a long time ago out of a couple of organizations where the core tenant of it was multi-tenancy. So it has very hard multi-tenancy built in, not sort of as an afterthought, but as like a native first step into it as well. And it's got a really stable API. Everything is API first, just like, Kubernetes and whatnot. But it has such a strong ecosystem that has been around for a long time. So, and it's super well maintained by a strong community of people inside and outside OpenStack, in my opinion.
Yeah, and I feel like, and the more open source projects, the better. And I don't want to say bad things about any other projects. I think where OpenStack is slightly different is the scale at which you can run it, whereas a lot of the other cloud infrastructure projects are targeting much smaller, simpler. And we've talked about Proxmox, we talked about CloudStack, we talked about others, and it feels like OpenStack has a complexity to deploy that's justifiable once you reach a certain scale. And when we started OpenStack, there were like big deployments, but it was like, so we would do as soon as the deployment would go above 10,000 CPU cores, we'd just give them a sticker, and we would promote them a lot. And then suddenly we realized that like everyone was running it with 100,000 CPU cores, and or more. And we're like, well, how about we upgrade the sticker? And then we realized that a significant portion of our users were running it at the million CPU core, which is like a very large scale. And so it actually scales really well. And so whenever you have that type of scale, that's basically OpenStack is the only solution that can cope with that and can actually like deliver that at that level.
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
I'm interested because Kubernetes is built for large clusters also. And it's really easy to manage your VMs as a pod. It's the same things. So I'm really interested. How does that compare to each other? Because I know you've got a longer state of you're longer running and older than Kubernetes is, but it's and even if Kubernetes virtualization is that's fairly new. It's like 5 years old.
I guess Mohamed can give you more practical examples, but what I've seen is like in terms of, there are like a few areas where running Kubernetes on top of OpenStack makes a lot more sense than running it directly. There is like the scale aspect, but also like multi-tenancy aspect. But we've also seen HPC use cases where people would get better performance running Kubernetes on OpenStack or using the abstractions that we have with the hardware than they would for running it directly on bare metal using Kubernetes.
For my information, sorry to abstractions with hardware. It's just you're running KVM or not?
No, like for example, I'm talking about direct PCI connections. Like you get some of the interfaces we have with Neutron, the networking project, for example, gives you better I/O with going through OpenStack, the OpenStack layers than Kubernetes. I was actually very surprised to learn about it, but Stack HPC, which is one of our member companies, is like delivering supercomputers based on OpenStack, and they're running their Kubernetes clusters on top of that. And so it's not just the usual use case is you need flexibility. You have some VMs, you have some Kubernetes clusters. Like, how about you have a substrate that lets you deliver all of that and probably something else tomorrow? Then OpenStack is a solution. If you already know you're going to run 100% Kubernetes clusters, maybe you just don't need to go through the hassle of going through OpenStack. But we've seen cases where you get actually better performance and they would rather run on OpenStack for especially supercomputing use cases. And that's because the drivers that are available through the OpenStack ecosystem to the bare metal is actually giving you that extra performance that you can't really live without.
Cool.
Yeah. And sorry, and on our side, like, I think one of the other core benefits is most, if not all, Kubernetes deployments on the public cloud are VM based. When you're working with, all of those hyperscalers, they're deploying your Kubernetes on VMs. And so there's a bunch of constructs that make a lot more sense when you sort of virtualize them. So for example, let's say you've got, 10 different storage arrays inside your company, and you need to make sure that you have a CSI driver for those 10 different systems. And then you also need to make sure that you have proper quota management for all those different systems and a way to agnostically access all that storage. Yeah. So for example, Cinder has been around for a while and it's got so many drivers for those different storage environments. So when you launch a cluster, all you need is a Cinder CSI driver. And you end up with volume types, and volume types can map to different storage backends. So if you've got a bunch of like NetApp and Pure Storage or Everpure, as they like to say now, right? And you've got a bunch of Ceph, maybe that's an open source. You can kind of just build different volume types and expose that in sort of one standardized API. And the other thing is also controlling sort of a trust layer. So, for example, if you are running directly on Metal, your Metal servers need to be able to talk directly to your storage arrays.
Yeah, but I'm not talking about I'm directly on Metal, but running Kubernetes in Kubernetes.
Yeah. But you would still, for example, how would you prevent a persistent volume? So, for example, in that case, you would need to have a CSI driver running that can provision those volumes for you. That CSI driver is generally going to need to talk to your storage array. Mm-hmm. And maybe with the multi-tenancy models, you'll end up having a lot of clusters that are talking in a privileged way to the same shared array. And so potentially one cluster can go, ooh, and then just maybe start deleting volumes of other stuff. Whereas with OpenStack, you kind of have this one sort of source of truth that is talking to your storage array at the end of the day. You also have other things like, so there's a cloud provider for OpenStack that exists out of the box. So it does things like allow you to create a service type load balancer and takes care of orchestrating and creating a load balancer or something. Now, I'm not going to, obviously there's Metal LB, there's a lot of other solutions for that aspect. But once again, it's like, well, you might need load balancers and other things. So why don't you use your own internal ELB equivalent, and Kubernetes can leverage it, but also VMs can also leverage it. The idea is that, again, I don't think everybody needs OpenStack. Some people, come in and just use it on bare metal. Actually, some people use OpenStack without the virtualization aspects. Oh, yeah. So like we've worked with folks and customers, and Ironic is one of the really big projects in OpenStack, and all it focuses on is bare metal provisioning. And it focuses and does it really at scale. And so if you're familiar with Metal Cubed under the covers deploys an instance of Ironic and uses it to drive all of the lifecycle aspects of deploying the bare metal nodes and everything like that. And so that's really, really, really a component that's strong on its own. And just kind of like one last thing to add is at scale, there's really nice things that it can do. So for example, bare metal, when you give someone a bare metal system, it's very privileged, right? They can change the firmware, they can do a lot of things. And if you're in sort of a multi-tenant environment or an environment where it can go from one to another, you really want to make sure that server is like as pristine as you can be. It's not someone that went into the BIOS and made some changes and whatnot. And so Ironic is great at like giving you servers and resetting them and updating their firmwares when they're being released, and not just wiping the disk, but resetting all the BIOS settings to where they need to be and the firmwares and everything to like really give you a full life cycle, like clean slate ability. So you don't need VMs. You might want to have a way to orchestrate all your bare metal because you don't want Bob mounting the virtual CD and going through the Ubuntu install step by step.
Poor Bob.
Poor Bob is doing it over the BMC console.
And it's also been interesting to see that like you can ignore that OpenStack is there. Like the visible part is Kubernetes. That's your interface to deploying applications. But a lot of the use cases that we've seen at this KubeCon were all running OpenStack under the hood. Like we've seen the SNCF trains, we've seen Ubisoft talking about their private clouds. This is all running on OpenStack. It's just we don't need to talk about it. We don't need to mention it. The German army having a private cloud in addition to like their multi-cloud technology, that's also running on OpenStack. It's all invisible infrastructure because nobody needs to talk about it because that's not the interface you're interacting with anymore. Kubernetes is the interface that you're interacting with. Yeah.
Okay. So if you look at this week, to take a little step back.
Went we too fast, man?
Oh, no, I can follow it. There's no problem. But if you look at where we were with OpenStack in 2016 and everybody moved to the public cloud, right? Mm-hmm. Now you see a trend back to sovereign clouds and private clouds. What are the biggest changes in OpenStack in this time period?
I'm not sure OpenStack changed. I think that the environment changed. Like, so there is...
Maybe new features that came from the hyperscalers.
Obviously, there is some amount of hardware support for latest GPU. How many different ways you can slice them to make sure you use 99.9% of them. So there is still most of the innovation in OpenStack is hardware enablement at this point. Like you get new NPUs, new GPUs, new ways to slice them and make sure you use them at the most capacity. And we need to expose that on the API layer in OpenStack. So that's clearly driving a lot of that. Otherwise, it's mostly about the OpenStack development. It's mostly about, it's like the Linux kernel. It's keeping up with the state of the environment, the technology. We want to make sure we run on top of the latest Python versions of library, latest KVM, latest kernels, all of that. And so that's what's driving most of it. We were talking about there used to be an explosion in new projects in OpenStack back when like everyone wanted to do everything with it. Kubernetes really simplified that by providing this universal interface layer for consuming those resources. And we don't have that many, database as a service project or a queue as a service project than we used to have. But at the lower level, we still need to enable whatever the hardware community is coming up next, DPUs, NPUs, all of the specialized hardware, and make sure that can be consumed through the ecosystem that we provide.
Yeah, and also there's a lot of things in sort of like the security side of things, secure encrypted virtualization, confidential computing, a lot of things in there that needed to sort of keep up with the new releases that these processors are making, and these manufacturers are sort of coming up with these technologies, sort of exposing them in a clean way, right? So maybe a couple years ago when we talked about doing PCI pass-through, we were talking about passing a singular GPU into a virtual machine. Nowadays, you've got things like NVLink, and you've got, things like GPUs that are working together. And so there's kind of a lot of work in the community and the project of like, okay, well, we went from expose one GPU or two to now figuring out, hey, how do we model a full topology of GPUs so that if you request two, you actually get a sibling that's connected with an NVLink rather than just one random GPU here and one random GPU there. So things like that sort of occur. There's also a lot of sort of latency related things that were sort of built in and high performance networking. So OpenStack is super popular in telcos. So a lot of the large telcos, when you're making these phone calls, it's all being routed through it. And as a result of that, they have really high network and latency requirements. So especially there's a lot of teams that work on enabling features like DPDK. Mellanox releases things like ASAP Square, which is their hardware acceleration for networking. And so enabling exposing that into OpenStack and making it really easy for users to leverage all these features. And a lot of times they can get near line speed. So you've got 100 gig NICs and you can have a virtual machine that can push 100 gigs, which is, not an easy feat, but it's a combination of different levels of technologies that all kind of culminate and get exposed in an easy way. So that when you create your Kubernetes cluster, you can get a virtual machine that can push 100 gigs very easily, Yeah.
Okay. Cool. Hey, and how do the communities combine the OpenStack and the Kubernetes community? Because you're on KubeCon. That's our event.
Mm-hmm.
How does that work together?
I think there's actually a lot of, like, if we're looking at a Venn diagram, right? There's a lot of like people in that are involved in both sides, right? A lot of the people that I see in open infra summits and events are people that I also see here. And you can kind of think of those sort of like infrastructure and raw compute platform teams that need to be on both sides, that need to make sure how to provide Kubernetes for their teams, for example, and the platforms that they're building for their teams, but also on the infrastructure side, which how they're consuming that hardware and building it out. So there's actually a lot of commonalities here. The other thing is a lot of the sort of projects which are inside Kubernetes, SIGs, and things like that are all sort of OpenStack driven as well. There's a cloud provider for OpenStack. There's a cluster API provider for OpenStack. A lot of these things are all, built from sort of the same teams that work together on sort of the both sides. So a lot of these communities, we meet here and we talk and we discuss and we sort of build in that. So there's a lot of things combined together. And I think another last thing is, believe it or not, for example, for us and other vendors are starting to do this, we run OpenStack on top of Kubernetes because it's one of the best ways to run an application. And so that's kind of one of the really popular things that a lot of people are doing now, which is rather than, spinning up, a bunch of servers and either running like a bunch of Docker containers or installing the systemd services, we actually leverage heavily cloud native tooling to actually allow us to run OpenStack in a super, super efficient way with things like Prometheus, with things like Loki, with things like all of these components help us run OpenStack in a better way. And so that's probably an interesting thing that a lot of people get confused because they're like, well, you're running Kubernetes on top of OpenStack, which is running on top of Kubernetes. And I feel like the follow-up is going to be, why aren't you just using the first Kubernetes?
And just we've been collaborating with the Kubernetes community for a very long time. Back when Kubernetes was started, obviously OpenStack was the big thing. And so we had lots of collaboration on how to organize the community, like what principles from the open. So when OpenStack was started, we started with the 4 opens: open source, open governance, open design, and open community. And open source, open design, open development, and open community. Sorry. So because back then it was not obvious that, all the development should happen in the open, like that you should have open pull requests, everyone being able to see the process in action. And so we collaborated a lot on transferring those principles, that plus the vulnerability management rules are inspired from OpenStack. So we collaborated a lot on putting up Kubernetes on a good track. Now it's like blossomed and became 100 times bigger. That's great. But we've been in touch really early on. And I would say right now there's like another round of closer collaboration because the OpenInfra Foundation joined the Linux Foundation last year. So, and the leadership is shared between our Jonathan Price, who was the executive director for OpenInfra, is now the executive director for CNCF. And so we're collaborating a lot on events. We're running an event in China that's going to be the OpenInfra Summit Asia, plus KubeCon China, plus PyTorch China. So we are collaborating on Kubernetes Community Days, make sure that wherever OpenInfra Days had a good organization footprint, we can invite the Kubernetes community to come, and the other way around. So it's a much more seamless environment. And I guess the digital sovereignty discussions kind of lean into that because that's what brings more people to using Kubernetes on OpenStack right now is that digital sovereignty push.
Cool.
Yeah.
Well,
Of a final question?
Yeah, no, final question.
Wow.
You can do that.
You can do it? No, you can do it.
You can do it.
Or should I do it?
Yeah.
Mohamed, if I would put a crystal ball here on the table, what would you like to see in it and relate to the future of Kubernetes OpenStack?
Yeah. I think right now everything is moving in sort of a great direction, but I think, and this is kind of like there's a bit of early signs that sort of started happening, and I think they're being addressed, which is great. But I think the Kubernetes project is working its way out to sort of like independence in the sense of really being 100% vendor neutral in a way. I say that because, for example, I know there's a lot of infrastructure still that's tied, that still is on its way to sort of being, extracted out and be sort of managed by the community, so to speak. Something in the sort of open infra world is that right now the people who have root access to all the infrastructure are actually community members that have contributed. So there's no part that is actually owned by a vendor, so to speak, or say, okay, hey, this little thing is actually driven by a vendor or something like that. So I see that hopefully that kind of removes a bit of the risk out of the Kubernetes project. And of course, I'm excited to kind of see the joint work together that we're doing, sort of like the LF and the Open Infra Foundation sort of working together and trying to make the ecosystem bigger, right? Because at the end of the day, right, like everyone, like there's no winning and losing when it comes to open source. We're all winning at this.
Not a zero-sum game.
Exactly. And we always say that, right? And so that's something we've always stuck by. And I think that, we continue to grow. And I think the us joining versus the Linux Foundation really sort of pushes to that. And my other sort of like thing, which is something that Thierry works a lot on, and I don't think he got a chance to share much about it, but the efforts sort of, especially in the European region, about open source and sort of like the governance around it and some of the legal aspects of it and how to protect it and how to protect the developers, how to protect the softwares. Those are really critical things that could be a big risk for open source as a whole. And so I'm glad, people like Thierry and all the other folks are working on stuff like that to sort of make sure that we have a good, sustainable future for open source in general, regardless of Kubernetes or OpenStack or Linux.
Or the next thing, yeah.
Exactly, yeah, exactly.
Okay. Thierry.
So I'll take a step back from OpenStack and because I think, so we have more than just OpenStack at the OpenInfra Foundation, and one of the projects that I think should get a lot more visibility within the CNCF ecosystem is Kata containers. Kata containers is basically running your containers inside a micro VM that gives you insulation security properties that you can't really get out of traditional containers. And what we are seeing right now is that the rise of like Kubernetes is running every workload. That means very sensitive workloads or having some compliance requirements in terms of isolation or running it into a multi-tenant environment or like running an AI agent that has to process some data that nobody has to be able to access. And Kata containers gives you that extra layer of isolation. It prevents the workload from getting out and infecting other workloads that are running on the same machine, but it also prevents the machine from seeing inside the workload through confidential computing effort.
Something like gvisor?
Yes, only in a practical way, because so gvisor, you have to rewrite your workload in order to actually be able to.
No, it's really easy. I can do a runtime change with the current containers and then set it to gvisor, or probably also to Kata containers.
In one of the gvisor modes, right? But if you use the syscall transfer thing, then you have to kind of run, like you can't really just switch it. And so Kata containers is way more like a flip the switch, add security. And I feel like, and it has like the confidential computing and the escape, like it has the protection in both directions. And right now with like the spread of containers on every type of workload, it feels like it should be the default in a way, security should be the default, like we all say. And so slightly working on getting more visibility. So as an example, NVIDIA, for example, is running Kata containers for their container-based workloads. They said that half of workloads need either multi-tenancy or extra security, and they're running them on Kata containers. You don't lose that much performance. You get additional security. I feel like it should be better known, and I hope that the collaboration between the two organizations is going to expose a lot more
awesome.
capabilities and being able to run that in very secure fashion.
Something to look out for.
Yeah.
Okay.
Awesome.
Yeah, Thierry, Mohamed, thank you so much for making time to join our podcast. And we'll love to follow up this in the future.
Thank you very much.
Thank you very much.
Take care.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple en alle andere favoriete podcastproviders.